Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is PT-3, Pythagorean Theorem with graphs. We'll start by taking a look at question number 3. Which point is closer to J, point K or point L, or is each the same distance from J? Prove your answer. If the points connected make a triangle, what would their area and perimeter be? So we have a lot going on in this question. Let's break it down. We can see there are 3 individual questions within this larger question. The first question is which point is closer to J? Is it K or L, or are they equal? So the first thing we need to do is to make a triangle out of these. And we can see that we have line JK and line JL, and those are the two that we're trying to determine the length of. So KJ is pretty easy to do. You can count the squares and we have 6, so we know automatically that that's 6. This one's a little more difficult to do. If this were a right triangle, we might be able to use Pythagorean Theorem, but it's not. However, you might see that we could, outside of here, create a right triangle in which these two would be the legs, and that would cause this line here, JL, to be the hypotenuse. And so we have to use 6 and 1 in our Pythagorean Theorem. So we have one leg at 1 squared, one leg at 6 squared, and that's going to equal c squared. So 1 squared is 1, 6 squared, 36, and we're still looking for c squared. 36 plus 1 is 37. If we do the square root of each, that frees c by itself, and we get a full calculator display for the square root of 37 at 6.08272653. But we really only need to focus on the tens place. And you can see that 8 would bump the tenths place up to a 1, so we can round the length of LJ at 6.1, which then makes it pretty easy for us to determine which is longer, right? If K is only 6 away from J and L is 6.1 away from J, K is closer to J. Okay, now that we've solved this part of the question, let's move down to number 2, which is the area of the triangle JLK. Well, in order to determine the area, we need to have a height. And so the height always starts from the top of the triangle and comes down to the base. So let's put a height line in here for that. The formula is 1/2 height times the base. So if we take a look at this, we can see that the height line that we made is 1, 2, 3, 4, 5, 6 high, and our base is 6. So it's going to be 1/2 6 times 6. So 1/2 6 times 6, or 1/2 36, equals 18. So the area of the triangle is 18. And since they don't give us a specific length for each of these squares, we'll just call them units. And whenever you're reporting on area, you have to do units squared. And that brings us down to the very last part of this, which is the perimeter. Now, to do the perimeter, we need to know the distance all the way around. And we've got 2 of those distances already. We started out knowing 6, and we determined that this side of the triangle was 6.1. So the last piece we need to find is this over here. Now, you may notice that the height actually creates a nice little right triangle right here. And so we can use this height line and the base as the legs to find this LK as the hypotenuse. The one thing you need to be careful of is this height actually cuts the base by 1 unit. So we're not going to use 5 for the base for this, or 6, we're going to use 5, excuse me. So let's plug these numbers in. We have a squared plus b squared equals c squared. 6 squared, the 6 coming from our height. 5 squared, the base minus the 1 unit because the height comes down to here, equals c squared. 6 squared is 36, 5 squared is 25. Together they give us 61. If we do the square root of each, we get a full calculator display of 7.810249676 equals c. Now, once again, we can go to the tenths and round that, The 1 doesn't make the 8 go to a 9, so we're going to round at 7.8 for C. And since that side is 7.8, we now have all three sides of our triangle, and now we can determine the perimeter. So we have 6.1, 7.8 plus 6 equals 19.9 units. We don't square perimeter units. All right, let's take a look at question number 4. A team of archaeologists fenced off an area ruined they are exploring. They created a grid to represent the area so they could label the location of several artifacts. For example, they found a pot at point P, a water pitcher at point W, a razor at point R, and a horn at point H, and an oil jug at point O. If each unit on the grid represents 2 meters, and I've highlighted that because it's so easy to skip over it, approximately how far apart are the following? So we need to do the water pitcher and the pot. So water pitcher is going to be the W, pot's going to be the P, and we need to connect those with a line like that. Now we also then need to create 2 more sides to make this a triangle. And so if we come from the bottom and work our way out as far as we can go until we get to W and then connect W down, we'll have created a right triangle. You can see with this being the right angle that the distance between the pot and the water pitcher is going to be our hypotenuse. So if we count by 2's, we can see this is 14 meters. And if we count by 2's, we can see this is 4 meters. So we have enough information right here to be able to plug these into the Pythagorean theorem. So we start off with a squared plus b squared equals c squared. Plug in the information that we got from our triangle. 14 squared plus 4 squared equals c squared. Gives us 196 plus 16 equals c squared. If we add these together, we get 212 equals c squared. Square root each of these. That gets c by itself. We get 14.56021478 meters. Full calculator display. And this time we can round, let's round to the hundredths place. So if we look at the thousandths place, 0, that's not going to bump the 6 up to a 7. And so we have 14.56 meters equals c. And so the water pitcher and the pot are approximately 14.56 meters away. Now let's take a look at the razor and the horn. So there's R for razor, H for horn. Let's connect those two. And again, we want to try and make a right angle out of this, so we'll make 2 more lines. And we can see, again, counting by 2's, that this is 3, so it's going to be 6 meters. And this is 2, so it's going to be 4 meters. And again, we have enough information that we can plug this into the Pythagorean theorem. So a squared plus b squared equals c squared. We have both legs. 4 squared plus 6 squared equals c squared. So we have 4 squared as 16, c squared as 30, or 6 squared as 36 equals c squared. Square root of 52 equals square root of c squared, which is going to cancel out. So we have c equals a full calculator display of 7.2111025751. And we can say that the distance between the razor and the horn is approximately 7.2, or you could say 7.21 meters in distance. Please use the work that was done for you tonight to help you to solve any additional problems that are on your homework. And remember, the key to success in math is not only working hard, but working smart.